how a 4-wire BLDC fan works and how we can control it using ESP8266.
Before wiring, let's see types of DC fans. DC fans may look similar on the outside, but their internal control and feedback systems are quite different. Let's break down how 2-wire, 3-wire, and 4-wire fans are structured and how each one works. A 2-wire fan is the simplest type. It has only a positive and a ground wire. Power directly determines its speed. More voltage means faster rotation. There is no built-in speed control or feedback signal. A 3-wire fan adds a third wire for tachometer, feedback, or RPM sense. This wire sends a digital pulse to a controller or microcontroller, allowing speed monitoring. However, control still depends on adjusting supply voltage. Controlling fan speed using voltage is reliable but less efficient and slower to respond compared to 4-wire PWM fans used in newer devices. And finally, a 4-wire fan introduces true intelligent control. The fourth wire carries a PWM signal, letting you precisely control speed without changing supply voltage. This design uses an onboard driver circuit that responds to PWM duty cycle, maintaining stable operation and a smooth acceleration.
Okay, we have a 4-wire fan here. We want to check which pins, which wires are for which voltage or which signal. Okay, mostly the yellow wire is for actually the voltage for the VCC or the power of the fan, like 12 volt for this fan, and the black one is for the ground. But this fan has not standard wires coloring, so I will try this gray wire, this one, as ground, and yellow wire for 12 volt to see what happens. Here, as you can see, nothing happened. So I think this gray wire is correct, but I need to check another wire. The green wire is mostly the RPM wire. So next step is testing this orange wire with the gray. As you can see, the fan works with the highest speed. So the orange wire is 12 volt and the gray wire is ground. After that, I want to test this yellow wire as the PWM signal. For this test, I just need to connect this wire to ground. It's safe because connecting PWM to ground send a signal like 0 duty cycle, so it will work if it is the PWM, and the fan will stop. Let's try it. As you can see, after connecting the yellow wire to negative pole, the fan speed is actually, the fan stopped, as you can see, and the current shows that the electronic board in the fan is working, but the fan speed is on 0. Okay, now we know the wiring. The orange one is for 12 volt, gray is ground, yellow is PWM signal, and the fourth one, the green one, is for RPM signal. It's feedback from the fan circuit. So let's try it on the breadboard with the ESP8266. Okay, now I connect the ESP8266 board to my computer to test this project. Now I will select my ESP board here this shows that my ESP port is working correctly. So I choose the main.py file, and here is our program. Here in this loop, it starts from 512 as duty, and after that it increases gradually by 50, and after it reaches to about 1000, it cycles in duty to 50. It changed the duty to 50, and this loop tries these numbers again and again, actually from about 50 to 1000. Let's try it. I connected the 12 volt negative to white wire and 12 volt to orange wire here. Actually, this duty works reverse. When the duty cycle increases programmatically, the duty cycle of the board actually decreases. It's because of this 2N3904 transistor that I put here. You can do it with some changes in your program or in your circuit.